Now we discuss the characteristics of scalar product. Scalar product of two vector can also be defined through another way. It is the magnitude of one vector multiplied by the part component of the other vector that lies in its direction. If we have two vector P and Q, here we draw the two vector P and Q. If we draw the perpendicular from P on Q, that is two component P cos theta and P sin theta, and this is the angle theta. So here we can write that P dot Q is equal to Q component of P in direction of Q vector, component of P in the direction of Q, that is P cos theta. So here we write P dot Q is equal to Q P cos theta. So we can write as P dot Q is equal to P Q cos theta. This is the one equation when we divide the vector P into its rectangular component. Now if we divide the Q component, here we take the two vector P and Q. Now we draw perpendicular from Q to P. Here is the angle theta. So this is the Q cos theta and this is the Q sin theta. So here we can write the scalar product of two vector P multiplied by the component of the Q. So here we write component of Q in direction of P vector. So here in direction of P vector, component of Q is Q cos theta. So here we write P dot Q is equal to P Q cos theta. So here we can write that P dot Q is equal to P Q cos theta. So here both the equations are true. So we can multiply by the two vector by this method. Now we discuss when the vectors are anti-parallel. Let's suppose here the vector P and this is the vector Q. Both lie in the same plane but in the opposite direction and make an angle of 180 degree. So here we write that when the vectors are anti-parallel, then theta is equal to 180 degree. When theta is equal to 180 degree, then cos of 180 degree, that is equal to minus 1. So here we write that scalar product of these two vectors P and Q, it is equal to the magnitude of P vector, magnitude of Q vector, and the angle between them. And the angle between them, that is the 180 degree. 180 that is equal to minus 1. So P dot Q is equal to minus P Q. So result of scalar product is negative. Now we discuss the when the vectors are perpendicular to each other, here is the vector P and this is the vector Q, that is make an angle of 90 degree with the P vector. So here we write that when vectors are perpendicular, then theta is equal to 90 degree, and we know that cos of 90 degree, that is equal to minus 1. So here we write that scalar product of two vector, that is equal to the magnitude of P vector, magnitude of Q vector, and the angle between them. So here is the angle is 90 degree. Oh, sorry, cos 90 degree is equal to 0. So P dot Q is equal to 0. The result of scalar product is 0. Now we write the self-scalar product. If we multiply the two vectors P and Q vector that both are in the same direction, here is the P is equal to Q. So dot product of a vector with itself give the square of its magnitude. So here we write that dot product of two vectors is the magnitude of the P vector and magnitude of the P vector and the angle between them.